Okay, first thing you want to do is you want to go to the Desmos website and you're going to click Start Graphing. But that's after you have your data, right? So after you have your data, which you should have after benchmark 2, when you fill out those data tables, you can start inputting your data into Desmos. But I do recommend to first make an account, log in, and save your data. There have been many instances when people have lost all their data and they have had to start all over again. So here I'm going to do a sample of one city, San Diego. And I searched on Google, population history San Diego. Great, I found a range from 1920 to 1990, and I got some population data here. So, great. I'm going to go ahead and start doing this for San Diego. I'm going to show you guys how we do our three models. The first thing you want to do is to step 2, create your table. You're going to go here to this plus sign, click on table, and there's your table. Now, from here, I just wrote it down in my little benchmark 2 packet, this data, and I'm going to go ahead and copy it onto here. So we have 1920, and we got 74,683, and we have 1930. And the numbers are growing. So you copy down your data that you got from the internet. You need at least 10 points. So again, this is just for San Diego, right? But if I was to do the artifact, I would also have to do the same thing for Oakland. We need 3 different models for each city. So basically that's six models in total, basically. 1960. Great. Now, I have my data. You would have to make sure you have at least 10 data points. We have 1, 2, 3, 4, 5, 6, 7, 8. So unfortunately, in this example, I only have 8. It's recommended that you have at least 10. But anyhow, let's go on. So I don't see my graph. So what you got to do, and then the handout that I gave you is step 3. You got to scale your graph. Right here, see, this is only going up to 40 here. Only going up to maybe 25 up here. So I got to fix my graph. So you're going to go to this little wrench right here. What you're going to do is you're going to put your lowest x value, which is right here, lowest x value, where you start. So I started at 1920, therefore my scaling is going to start from there. My highest x value is at 1990, therefore that's my highest x value, 1990. Good. Now my lowest y value now, the range is going to be this number right there. The range will probably be large for all of you because the range is giving us the population. You know, and make sure you know what x and y are because you got to interpret these. See, now we see graphs. The dots, I mean, not graphs, the data points start to come out. I'm going to zoom out a little bit just so I can see them. Great. Now let's go on to step 4, which is to create the 3 models for my city right here. And this is San Diego. And as you can see here, if I was to be signed in, I would be able to save this graph so that I won't have to redo this again later. Make an account and save your graph. So I'm going to start with my linear model. In Desmos, your linear model has a specific format, and I gave you a handout on how you're supposed to write those specific formats. So my linear model in math is y equals mx plus b. But in Desmos, you have to put y, you have to put underscore 1, then you have to put a tilde, and then mx, and then after the x, you put an underscore 1, and then you have to put plus b. So there we go. Here's our linear model. It creates a best fit linear model for our data points. we're going to take a look at this r squared value, but the cool part is it gives you the equation. It gives you the slope right here, the m, and it gives you the b right here. The b would go right here. Great. So now that's my linear model. Let's go ahead and do the quadratic model. So again, I gave you notes. It's on step 4. The quadratic model is y equals ax squared plus bx plus c. We have been working with this, with factoring and finding the vertex of a quadratic model. So in Desmos, similarly, you're going to write it as y underscore 1 with a little tilde symbol. And then ax sub 1. Then, because the first term is squared, you're going to put squared. And by the way, there's a squared symbol right here if you're having trouble doing the squared. Plus bx sub 1, then plus c. See, this is y equals ax squared plus bx plus c. So here, this black line right here is our quadratic model. I'm going to zoom out a bit. As you can see, it's U-shaped, passing through our points. It gives you a, b, and c. So you could actually create your equation. And this is when the predictions come in. Once you have an equation, you're going to have a function. And once you have that function, remember, functions are useful for making predictions. And that's how you're going to be answering your essential question. Lastly, let's go on to the exponential model. The exponential model was the one we introduced right before we started this artifact. The exponential model is y equals ab to the x power. It has a variable as a power. So again, y sub 1, you're going to shoot back up, put your tilde, you're going to put ab, and then you're going to put x to a power. And then you still got to put underscore 1 in order for this to work. Great. Now this the red line right here, this red line is your exponential model. Let's zoom out a bit to see that a little better. There you go. Exponential model is very close to the x-axis, then it shoots up in growth. Okay, so then you could go ahead and start to analyze these. Let's go ahead and start taking out all of these right here. So here's our linear model. Let's take that out. Here's the quadratic model. That's there. All right, let's take that out. And then here's the exponential. Now, which one do you think made a better fit for our data? If you were to visually see, where do the dots line up most? This one kind of, yeah, I see that happening there. This one, whoa, I see a lot. I see this line right here hitting most of the points, actually. And then lastly, the exponential. I only see this exponential hitting like one, touching two more, but just hitting mostly 1 point. So from my observation, my best model would look like this one, right? Okay, but in this artifact, you're not going to choose your best model by visually seeing where the dots line up. What you're going to do is look at these r squared numbers. These r squareds are called coefficients of determination. Usually, the closer that this number is to the value of 1, the better your model is. So which one has a number, the r squared, coefficient of determination closest to 1? This is 0.96, around there, or 0.97. This one's 0.99, and this one's 0.8338. So since this r squared value is closest to 1, I am going to choose this model to make my predictions. And that's how I would make my prediction for San Diego data, and I'll be able to answer the essential question of what will be the population in 2050. And once I have my Oakland data and I have my 3 models for Oakland, I'll be able to then therefore answer when, if ever, will the 2 populations have the same number of people. So that's how you do your 3 models. You will need to have screenshots of every single model in your slides. You have to show me the screenshots. You have to show me these screenshots. So basically, do make an account, sign in, and save your data so that you can return and take your screenshots. You would also need your table data as well up here. You would need screenshots of all of that, evidence of your work. Other than that, this is how you use Desmos. Look forward for some more tips. If you're still having trouble, like I said, there's often